Hi everyone, this is Phil Laidler. I'm the Consulting Director at STL Partners. Welcome to our webinar on digital twins. Good, I guess, evening for those of you joining us from Asia. Good afternoon from those of you joining in Europe, Middle East and Africa. And good morning for those in the States and Americas. So the theme for today's webinar is digital twins. And just to explain the title, the title is digital twins just about better graphical digital representation, or as we are going to argue today here, is it actually a key enabler for the Internet for Things? A lot more than just digital representation, a lot more than pretty things. And that's really the question we're going to cover off on today's webinar. And it's going to be presentations from Darius, my colleague, a consultant here at STL Partners, and he's going to be followed by Paul Green, who's the CSO Iotic Labs, and they're both going to sort of address this question and set out what essentially we see digital twins are, why they're more than just representing the world digitally, and what are the implications both for the Internet for Things and ultimately for the wider ecosystems that enable that. Great, so welcoming everyone and handing over to Darius to start the presentation. Over to you, Darius.
Perfect, thanks a lot, Phil. So what I'm hoping to cover today is a little bit of the overview of digital twins. What are they, what are some of their uses, and touch kind of quite quickly on what is the potential role for telcos within that ecosystem. So to kick things off, we like to start with a vote, and today that vote is, what does a digital twin mean to you? And the reason that we really wanted to ask this was, depending on what walk of life you come from, you might have a different point of view, a different perspective, and digital twins could mean something different. So hopefully you've all got that poll open on your screen and you should be able to kind of cast your votes. So kind of option one, is that digital twin really around that better visualization of your data? Is it around more complicated and sophisticated analytical models, whether that's simulations or emulations? Is it purely a virtual source of information on an asset? Is a digital twin really a way that you can share data more easily across an organization, but also outside of organizations? Or is it really, as Phil mentioned, just a general step towards digital transformation? So if we give you another 5 or 10 seconds to start to get some of those answers in.
Hi, while you're doing the vote, this is Phil again. Just while you're thinking about that vote, just want to mention that throughout the course of this, we'll be happy to take questions. So if you've got any questions you'd like to ask to either Darius or to Paul, so we'd like to go through some of those questions at the end of the webinar, then please do so anytime through the control panel. Please enter your questions and we'll be monitoring those and feed them back. I think we can go back to the poll now.
Okay, great. Yeah, so as expected, quite a diverse spread there. A few of you kind of leaning towards that more complex analytical models, but not really a consensus, which is quite interesting and sets up my presentation hopefully quite well. So starting off, what is a digital twin? And while there isn't necessarily consensus or agreement about what a digital twin means for you guys, I think there is consensus, at least at a high level, as how we define a digital twin. And that is, a digital twin is a virtual representation of an asset, providing both an historical ledger of the asset's previous states, so it's a record of how that asset has behaved in previous times or locations, but also, and this is quite important, a real-time source of information on that asset. So it's providing a source of data on the asset's current state. So yes, there's consensus on that, and we agree that's probably what a digital twin is, but what it enables and what it can be used for by an organization changes. And this is why here at STL, we've developed what we like to call the digital twin continuum, or the digital twin kind of roadmap or evolution. And it looks a little something like this. So there are 4 stages. Stage 1, visualization. Stage 2, advanced modeling. Stage 3, T2T or twin to twin process automation. Stage 4, cross ecosystem communication. Now, before I kind of dive into the details of what each of these stages means and what it represents, it's important to note that this is a generic evolution of digital twins and how the market itself might evolve. So specific organizations who are more technically mature might choose to join this roadmap and this journey at different stages. So they won't go through stage 1 through to 4 necessarily. They might join at, let's say, stage 3 and explore the use cases there. And also, it's not to say, you know, organizations that are exploring visualization use cases won't also be exploring use cases or components of use cases within stage 3 and 4. But what this does represent is how a general trend for how the market might move. So if we start on the left-hand side with visualization, this is really around organizations using the digital twin to create new virtual dashboards, those quite complex 3D visualizations, potentially virtual reality, mixed reality. And you know, you might say, okay, well, things like that have been happening for a while. I think what's different about a digital twin here is that, in my opinion, the digital twin isn't necessarily the visualization itself. The digital twin is really that source of data, as kind of said in the definition, which enables tools to create those visualizations. So you can get different layers of abstraction. Also on top of that, what you have is the incorporation of real-time data on that asset. So you're not building a static visualization, you're actually building a dynamic representation of an asset. And kind of following on from that, within this stage, the digital twin is enabling at least some basic level of analysis. So you're creating data-driven insights on your asset already. It's not just, as I say, a static model where you can look and it's okay, it's nice to look around, but it's not really giving you any extra information on the asset that you've developed. Okay, so then we move into stage 2, which we've called advanced modeling. And this is where you're using the digital twin to enable quite sophisticated simulations, emulations, some kind of, you know, AI-driven automation. And you know, this has quite good applications for industries where you have quite complex pieces of machinery and you want to innovate and make those machines as optimized as possible. So I've got the example here of a jet engine where historically you'd have to draw plans and then make it and test, and those cycles of R&D are quite long and arduous. Whereas when you have these assets in a virtual plane, essentially you can test and run quite detailed what-if scenarios to actually streamline those R&D processes. Now, on top of that, what you start to introduce are, as mentioned before, these kind of machine learning and artificial intelligence capabilities. Now, in the previous stage, you're incorporating real-time data into your digital twin. But here, what you can start to do is actually real-time analysis through that kind of machine learning and artificial intelligence. And so you can start to generate predictive maintenance alerts. So if you have a quite complicated machine out in the field, you can essentially assess whether that machine needs to come in or whether an engineer needs to go out and fix it. And in that way, you can quite drastically decrease downtime. So as we move then into stage 3, which we've called twin-to-twin process automation, this is quite a big step and it's quite a big jump between stages 2 and 3. And the reason for that is because what the digital twin represents shifts slightly. So in stages 1 and 2, you have the digital twin probably representing a centralized data silo where you're starting to store a lot more data and collect a lot more data. Whereas in stage 3, what you have is digital twin becomes a lot more granular as to what it represents. And instead of representing a data set of a whole asset, it can be quite on a specific level, you know, representing a specific sensor or a group of sensors. And as you start to collect these sensors together and form composite digital twins, that's how you start to build a picture of your whole asset. And as you do get more granular with these digital twin representations, they can start to communicate with each other and form these quite intricate closed loops and sophisticated closed loops so that you can remove the need for human interaction and twins can react based on what other twins information are publishing, and you can have twins that are providing controls and you can start to automate certain processes and drive real digital transformation. So it's important to note here that yes, you have twin-to-twin communication, but that tends to be within an organization. You know, yes, an organization might be able to ingest exogenous data, but really that communication is happening 2 ways just within the organization. Then as you move into stage 4, this is where that twin-to-twin communication starts to move beyond the boundaries of an organization across the entire supply chain or across the entire ecosystem. And this is where, you know, this is kind of IoT nirvana as well, where you essentially have this open data platform and a mesh of sensors which are all interacting and communicating and sharing information so that you can have much more reliable collaboration models and actually start to innovate as an entire supply chain more effectively. So as you move further up the continuum, essentially, what you're doing is driving digital transformation, but you're also increasing data centricity. And I think this is quite an interesting point, and I'll touch on it on a later slide. But essentially, stage 0 of creating a digital twin is very much getting your data management processes in order, ensuring you're collecting your data in a smart and effective way so that it's easily accessible and it's not noisy, and anyone can come in and from your organization and see exactly the layer of abstraction that they need to. So bear that in mind as we go into the next slide, which is looking at why digital twins. So I think before I kind of dive into the details, it's important again to say digital twins, at least from my point of view, isn't necessarily a new technology. It doesn't come with drastic changes to the technology infrastructure. You can run it on pretty standard core cloud workloads. And so essentially what it really is doing is providing a philosophy of data centricity. So a digital twin provides quite a tangible entity for board members, for senior executives, for the people who are actually implementing the solution, to actually show what good data practice can do. And it's something for them to work towards. It's a milestone in order to actually drive this kind of data best practice. So how do those kind of benefits map onto that digital twin continuum or that evolution? Well, one that sits across and one that Phil mentioned earlier is this idea that digital twins help to enable adjacent technologies, one of which is IoT. Now, IoT is very much centered around more and more sensors at a more and more granular level to create more and more insights on your assets. But creating more and more data isn't always going to turn into information. You could end up with a data set that's too vast and too noisy. And so essentially implementing the principles of digital twin and that data centricity helps you to make the most of the IoT, and it's how the IoT maybe was planned that it should be. And as you move slightly towards the end of the continuum, stages 3 and 4, where you have digital twins of specific sensors, these become very smart, and they can, on a very specific level, decide what data is and isn't stored. So you're collecting your data in a much smarter way. So how do digital twins then enable AI? Well, we've written before about AI needing 3 things. That's clean data, up-to-date data, and accurate data. Now, as I've kind of mentioned already, digital twins very much help with the clean data. And if we go back to kind of that high-level definition of what a digital twin is, we see that it's that historical ledger of real data based on that asset. So it has that accuracy, and it has the real-time data coming from the asset's current state. So it's up to date. So you have the 3 components needed to build sophisticated AI models. And on top of that, you essentially have created a virtual layer in which you can test, refine, and deploy. And we saw that in the R&D use cases. So essentially, you have this virtual layer with all of the ingredients you need for AI, and you can train that algorithm, you can test it, you can deploy it, you can refine it in a virtual space without having to necessarily impact the asset. So you're quite drastically increasing the progress and the innovation around AI algorithms. So that was kind of how it enables adjacent technologies. But what about kind of the key business indicators or the business drivers? And the way that we see it is, when you're at the first stages, or the initial stages of digital twins, really it's around cutting costs and increasing operational efficiency. And I think you see that with quite a lot of other technologies where that initial investment is very much driven by margins or the need for increased output with the same cost, or the need for the same output with less cost. And this is exactly the same with digital twins. However, when we start to progress up the evolution of digital twins, it starts to see organizations start to look, how can I translate some of that benefit back onto the customer? And I think a good example of this is IBM Watson and Kone, who are a lift maintenance company. And they essentially started within kind of what we've called stage 2 digital twins. And they were running some analysis to assess, okay, how does my asset or my lift perform in the field? This was intended to reduce the number of truck rolls that they had so that they could leave lifts operational for longer. But what they eventually realized was, okay, we can start to be proactive as opposed to reactive in dealing with our customers. Because usually a customer would only ring up if the lift in the building was broken. But now they start to change that relationship and put almost the customer on the back foot in terms of when they're reaching out to complain. And you can start to build a more interesting relationship, which could lead, if you think about other industries lead to more upsell or cross-sell opportunities. And then this kind of leads us into our next point, which is as you progress, you start to explore new services, new revenues, and an example of that could be in data monetization. So as you start to collect more and more data in a smarter way, and you start to expand that data set beyond the boundaries of your own organization, you end up with quite rich data. And this is a clear monetization opportunity in terms of selling those insights, kind of a B2B2X play. And the last one there, new business models. And I've got EAS written down, which stands for everything as a service. And some of you may know this as servitization. And this is essentially the idea that if I have a quite expensive machine, I don't necessarily want to pay all CapEx upfront for that. I want to change that more to an OpEx model where I'm paying per use, or I'm paying as I need it. And as you start to collect more and more data and store it in your digital twin, you can see quite clearly innovative ways that you can start to charge your customers, or how are they using my asset, so that you can then better refine your product, but also better refine your charging models. Okay, so the final point that I wanted to touch on is kind of what's the opportunity for the telecoms operator? And we see that opportunity as twofold. The first one being they can leverage digital twins internally as an end user themselves. And I've got 3 examples here. There are more, but I just chose these 3 because I thought they were interesting. So essentially, you can create a fertile test environment. And we've spoken about this already in terms of the AI and the R&D, but if you imagine this in terms of a virtual network where you're deploying virtual machines and network functions, this is quite a good way to test in a specific area without deploying throughout the entire network, and make sure it's working. How can I optimize this? How can I deploy this quickly? So you can decrease deployment times, but also increase the efficiency of those deployments. You can increase data visibility and access. That's the second bubble. Now, this is quite an important one, not just in terms of analytics and sharing of data. You don't want to have data strategies siloed within an organization, and we've written before about the need to centralize data silos. But what digital twins enable is, you don't necessarily need to make an enormous central repository, because the digital twins allow you to share data across that organization already in the way that they're implemented. And so it allows telcos, which traditionally or historically might be a little bureaucratic and a little slow moving, to be more agile, because they have access to data that they need, and they can all see the information that they need to at the right time. And the last point here, improving network operations. So when I put this down, I was imagining kind of a telco hosting a private network, for example, on an enterprise campus. They need to make sure that that private network is running at optimum performance. They need to make sure that they're meeting any SLAs that they have in place. And so they need to continuously refine how that network is configured and how it's operating. And that can be done using digital twins of the network, where they can analyze, and you can create those closed loops to actually assess what the best path is for data packet movement, or how to configure in a different way. And so that's kind of another way that telcos could leverage digital twins internally. Now, I wanted to hit quite a few buzzwords in this presentation. So I've hit IoT and AI, hit NFV, and I want to mention 5G as well, because 5G will dictate a cloud native core. It will dictate more virtualization, and to kind of provide that ultra reliable low latency comms, it needs to be fast. It needs to optimize quickly, in terms of things like beamforming. It needs to have constant analysis going on. And this can, be quite significantly improved with the use of digital twins. So the second way that telcos can benefit is to act as an enabler for twins. So we've seen this with the IoT. Digital twins enable telcos to move beyond their traditional verticals, but beyond consumer and maybe office-based broadband into other verticals. So they can move into manufacturing, logistics, utilities, and they can start to provide a service beyond connectivity, which is my next point. So yes, you can start as connectivity as the first thing that an organization would implement with this solution, but then telcos could take a role more as a systems integrator or as a solutions aggregator, and maybe act more as a managed service to provide those verticals more and more value. And this is a good way for telcos to kind of combat the commoditization of connectivity, which is something, again, that STL has written about. And kind of think, as connectivity becomes more prevalent, yes, you will be gaining more revenues, but your actual revenue per user might be decreasing. So this is a good way to start to kind of tackle that issue. And the last one here is distributed compute. So by no way do I think digital twins will drive a move to the edge. But what I do think is that if edge infrastructure is there and edge capabilities are there, digital twins will leverage them. not only in terms of meeting the latency requirements that will start to exist, but also in terms of making those smarter data decisions. So you have an edge gateway or a device edge, which is making decisions on what data is stored in the core cloud. So you can quite significantly reduce the actual volume of cloud storage that you're needing to use, and you can then decrease your price as well, because storing all that information can become quite costly. Okay, so that's kind of all I wanted to cover from my side. If you do have any questions, as Phil said at the beginning, you can put them in the box. I'm sure I've missed something, or you've got something interesting that I haven't covered. But for now, I wanted to hand over to my colleague Paul, who will cover some of the real world digital twins use cases and start to add a bit of practicality to the concepts that I've laid out. So handing over to Paul.
Okay, well, hello everybody. My name is Paul Green, and Phil kindly introduced me earlier on. And I bring, I guess, some of the, hopefully some practical ballast to this conversation by describing some of the things that we've been experiencing by implementing a real world environments for digital twins. And the space that I've come into here is the one that Darius alluded to, actually starting really at stages 3 and 4. So we know of quite a number of companies that have already invested in substantial work to put into place some good visualizations of their data. They've already got quite a lot of representations of their own businesses in their internal management systems that can be involved in lots and lots of different environments. But they've run into a lot of problems, and so here's some I'll introduce some general charts that describe the issue that some of our users have had, and then I'll talk about a couple of actual implementations. And the first one is that this diagram that rather sort of practically illustrates the done by variation versus Metcalfe's law. So it looks very pretty and it's kind of intuitively obvious, but the number of things that can interact is kind of limited. And we all know that in our own businesses, we know it in our personal lives, we know it in the rest of life. And what's happened is we've solved some of those problems by creating some dashboards and some cloud-based tools and all of those clever things that we've got. But there's a massive opportunity as things start to interoperate on a wider basis. But that requires something significantly clever to be able to make that happen, because you have to be able to share things and still keep degrees of privacy and security attached to them, as well as know that actually the stuff you're sharing is real stuff and not something you just made up. So we come on to the next slide, which is this idea of interoperability. And this rather entertainingly describes the basic level of interoperability as being the swivel chair, which we kind of all know from the times when you've got multiple screens in front of you and the operator moves from one screen to another in order to be able to see all the relevant data to their business. And although we might think that that's something of the past, one of the people I'll be talking about in a minute is actually still doing that with 8 screens in front of them. To solve some of those problems, we've introduced the idea of standards and protocols that makes it so that stuff will sort of theoretically talk to each other, and that's worked to a degree, but lots of people have found it challenging. Even if you're using the same standard, the same protocol on the same site, lots of things that are from different suppliers and manufacturers still don't talk to each other. To solve some of those things, some of those SaaS systems inside our businesses, we've had enterprise service buses, and of course that's progressed naturally to the idea of kind of single platforms, which we've often called Internet of Things platforms, data lakes, or whatever. And they're great, but they've got the limitations, because quite often people have got multiple platforms, and as somebody said to me recently, it's great, I've got 13 IoT platforms. So has it really helped? Not entirely. So maybe this twin-to-twin technology can actually solve that by creating an ecosystem that will work between the different data lakes we've got, the different IoT platforms, the legacy systems we've got. My goodness, most businesses they're swimming in data, but it's all over the place and it doesn't join up, and they'd love it to. And I say, can't we just make it work together and do some simple stuff? So Moving on, we've also noticed that in doing that, I'm not sure we've missed a slide there, but in doing that, we're looking for being able to monitor stuff together. So we want to be able to pick up controls that might be monitoring things. We want to make sure that interoperability works in an autonomous way. But most significantly, in the bottom box where we've got data and data coming together from both the source and the consumer, we want to make sure that we've got a single source of truth that we understand is right, we can believe in and we're confident in, so that we can get management systems and interoperability that actually works in flexible ways. For different people, all want different things, but they all need to interact together. So, I think our next slide will go on and talk about an example, an illustration of that. Because where the data and controls need to interact, they're often derived from different sources that might actually be operating through different forms of connectivity. And what's tending to happen is that organizations are just expecting the connection to work, and they don't care really whether they're working with a Wi-Fi or a fixed network or something that's very specific to a certain site. And quite often they'll want some of those data sources to be grouped together into groups of twins that are privately held, but they also want those privately held twins to often interact with the more public networks as well, that might have twins of all kinds of very basic sources of data, such as things like weather and water levels, but it might be other things like sort of more sophisticated changeable data like railway information or transport. But often in all of these situations, we've got structures where the relationships between things are not permanently defined. They're transiently defined. So somebody might be going down the street and want that data now from the sources of, for the twins of things that are around them. But then that piece of equipment might get deployed somewhere else in 3 days' time. Or it might be that my medical product that I'm wearing at the moment needs local information, and I'm actually in a different place when I need the next connection. So how can we make that work so that we can not only pick up data and enable controls, but make it so that we can have all of this stuff working together in a way that allows transient as well as permanent connections? Well, that's the challenge that we set about trying to solve in Iotic Labs. And actually what we ended up coming up with was creating what effectively is an interoperable ecosystem that brokers data and controls, and it does so securely. I won't describe to you how that technology works, but I'll just describe how 1 or 2 people have used it. And we have got some substantial large-scale organizations that have adopted this. One I'm going to describe at the moment is a company called BAM Nuttall, who is a really large-scale construction organization. And they had some really practical problems, and they created with us, using the Iotic space, a thing called a learning camera that literally watches paint dry, which is something I'm sure we can all relate to. So the next picture actually will show an illustration of this and the components that were needed. And this related to the bottom left-hand corner. You can see a construction site that's right next to a railway line and somebody squeezing between a fence and some hoarding. And then the next picture along shows them looking at the piece of equipment that needs to be monitored. This is legacy. This was a legacy equipment, and it was performing a pretty vital task on this site. Because it was actually a compressor that was absolutely essential to keep all the equipment working on site. But the challenging problem with it is the only thing that told you whether it was working properly or not was a couple of little lights on the outside of it that couldn't be reported, that didn't have any mechanism for sharing that information across the multiple parties that were working on site. And so we created a very cheap little webcam that watched this device, which is solar powered, connected to a Raspberry Pi, that actually is able to publish that data into this interoperable ecosystem. so that it could have added to it additional data sources such as weather conditions and air quality and so on, so that that would be combined together in ways that was suitable for the different people who were coming to that site, even if they're only temporarily located there, to pick up data. This could also be conveyed into conventional systems like a dashboard, but it could most noticeably was there to provide simple notification and alarms for the operations on that site. Was simple, practical. The great thing is it can now be picked up and used elsewhere, and so now it's being used to look at surfaces so that they can tell whether the paint has dried because it changes its luminescence when it becomes dry. So they know where they can go and put the next coat on. The painter who's there on the site knows that that's available at that moment, doesn't have to have any special tools, can find out, doesn't need to be told what to do. It can also be used for 100 other things. So this is being deployed in all kinds of building contractor space at the moment. But as you can imagine, building sites are brilliant to explore in a greater and more diverse way. And as a result, we found ourselves expanding these projects because a building site is essentially a very large outdoor factory where the people in your factory only work for you from time to time. The materials are being delivered in a kind of, well, disorganized, you want to organize them, but they're actually delivered in all kinds of less controllable ways because you're delivering concrete and steel largely, and you've got lots of machines and equipment that need to operate together, but all of them are coming from different suppliers and quite a lot of them are rented. So much of the equipment is working on the site and it's all communicating back to various management tools and systems that are all working happily in the internet of their own things, but they're not able to share it with the other pieces of equipment that are all working together theoretically to produce the job that they're doing on the site of building something. So as a result, what we've been doing here is creating a kind of digital marketplace for data, so that then things can interoperate and interact with each other in extraordinary ways. And each piece of equipment can have its own event history, and the building itself, the equipment itself on site, actually acquires its own event history as it's constructed. So that the process of this is actually, although the things that are all working together are twinned, the thing that you're creating is also forming its own twins in the process of the creation. And so what you find happening is that the event logs that become associated with it actually take on a life of their own. And you've got as many virtual things here as you have twins of real things. And then these things actually enable you to have a data-rich environment that can then gain information from external tools, gain information from external systems that you might already have, the likes of SAP or maintenance systems and so on, but also generate information that can actually run it into the future of the life of that building or their structure. So there's some practical things that we're doing, and it's changing the way in which these organizations are operating.
Great, thank you very much. So thank you, Paul. I didn't get a chance to really introduce you properly, but for those of you who are not familiar with Paul, he's a sort of successful, serious entrepreneur who's actually been involved in a number of successful businesses that are in the business of making connected stuff work. At least that's how I think of it. And his latest venture, Iotic Labs, is very much at the forefront of putting some of this digital twins thinking into practice. And thank you very much for sharing those examples. I'm sure that we're going to get some more questions. So I'd like to invite all the listeners to put their questions to Paul and also to Darius in terms of what you've seen and heard today. And I think we've already got some questions here that have already come in. So I'm going to kick it off with the first question that's already been set, which is, and this goes back to your 4-stage approach, Darius. And the question is, what technology or business models and other enablers will be required to move from stage 2 to stage 3? So what are the key enablers to get us from stage 2 to stage 3?
That's a tough first question. I think one of the key ones are people like Iotic, who help to define the ways that these things can start to communicate with each other on quite a specific level. But also it's around not trying to create too many standards, because when you get to these quite large scale organizations, they aren't going to be sharing each other's standards. They're going to want to work with their own. So it's as Paul kind of mentioned, it's around how do you drive interoperability around those standards, and people like Iotic are the ones that start to help to bring some of that together. And I think that's quite the kind of important change between stages 2 to 3 and 4 is really around that interoperability, because what you're doing in stage 1 and 2 is quite contained within your own organization and your own assets. And as you start to progress, that's when you have to open up your platforms, and that's where interoperability becomes quite a key part. And I think that's essentially where you'll need to partner, or you'll need to start to assess how you can build your data in such a way that it's easily accessible by multiple third parties.
Paul, would you agree with that, or with Darius's sort of interpretation of the question?
Yes, it's quite a challenge for most organizations, and the challenge comes in two parts. One is finding a technology partner that can help you do that. Well, clearly I'd like to say Iotic Labs actually enables that to happen. And the key thing is not, as Darius said, having to agree everything as a standard to begin with, taking what you've got, because your chances are you've got a lot of stuff already, just that you can't get it to interoperate. But the second thing, and the most important thing that we've discovered, is the organizational mindset. It's being able to think in a way that's more like thinking about the internet than it is thinking about connectivity and telecoms. So that you're thinking of it being more like a community, more like something like Facebook would be, where lots of different things can interact together, and as they interact, they produce new things. And that actually that requires a new way of thinking about how you're going to use your data and how you're going to interact with your own supply chain and ecosystem.
Right, I'm just waiting to see if there's any more questions come in. Oh, I'm having difficulty accessing them. Why can't I see the question? Ooh, bear with me a sec. I have to change the view. Okay. Next question. Here we go. Actually, there are two from Ricardo. One is, what are the technical requirements for someone to sort of to join an ecosystem or a marketplace? And the second question is, do you have to do that yourself, or is that hang on, I'm getting more and more questions coming now, which is great, or is it one-on-one tailor-made, and are there sort of standards that you would promote or share? I think that's a question to you, Paul.
Yes, okay. There's quite a lot in that question. Sorry, am I on now? Yeah. There's quite a lot in that question, and I'll try to answer it quite simply, because otherwise we will be here for a very long time today. The most important thing that we've tried to do in this Iotic space is to build it so that you don't have to comply to a lot of special standards. What we've done is we've made it so that if you've got devices that are producing data in something like MQTT, for example, they can directly integrate into a space like this. Quite a lot of devices will generate data in a form that can be used directly. And what we've created, though, is a key thing with this, is that you do need to be able to search for and discover the devices that you want to interact with. And so what we've created is a capability for you to be able to search on the metadata associated with the device, and then the device has permissions and controls about who can actually get the data from it. So you might know that it exists, but only the particular people in that community can actually acquire the data from it. And that there's actually no direct interaction between the device itself and the person that and the receiving piece of equipment. Otherwise, there will be inherent risks and vulnerabilities. So those two things have sort of come into play together. And if it's more complex systems, like say that the data is all in your internal data management tools already, then quite often there's interfaces to that, but it's the descriptors so that you can find what's relevant and make it available to the community that is as important as the technical interfaces.
Thank you. Another question here from Lakshmi. Another question here from Lakshmi, and I guess, I mean, most of the community here on this call and ourselves, as you know, Paul, is built around telecoms operators. So this question is a little bit more directed to whether you're aware of current state of adoption within operators of digital twins, and both for their enterprise processes and customer journeys within the telco, and I guess also within maybe their solution teams that are trying to address challenges within their customers. So are you, and actually I'll start with you, Darius, are you aware of any particular use of these concepts within operators, either for their own internal processes or as part of solutions they're offering to their customers?
I think primarily I've at least seen it as telco as an enabler, so not necessarily using it internally, digital twins, but certainly providing the connectivity that allows digital twins to connect back to an organization. So one example was a lawn mowing company who had lawn mowers that were out in the field, and they wanted to understand more and more about their lawn mowers and how their customers were using them. And essentially, you know, the telco was able to connect those back to a kind of virtual dashboard initially, which that lawn mowing company could see, okay, you know, people are mowing this, I need to maintain X rota, or I need to improve this part of the machine. And then they would move into the kind of stage 2 twin and start to run those analyses to assess, okay, well, how can I best optimize that lawnmower? And so what the telco was doing there hadn't strayed into the managed service layer, hadn't strayed into the SI. It was primarily around the connectivity to allow the digital twins to communicate. But I think, you know, if a key kind of internal potential use case, I haven't necessarily spoken to anyone who's implementing it, but one that we have done through other research into analytics is this idea of, you know, creating a centralized data silo is important in terms of driving machine learning and AI progress. But there's a point at which you can only centralize so much before it becomes unwieldy. And so digital twins, you know, we've spoken about as a key way to actually share that data across an organization and kind of remove those siloed data efforts without creating just a huge central repository. And so while we haven't seen anyone implement that yet, it is one that we've spoken to people about, and it does seem to have some kind of traction.
Okay, quickly, Paul. Yeah.
Just one more thing I'd like to add to that is that what we've noticed is that the telcos obviously provide the infrastructure that's key to making the communication work into and through digital twins between the sources, the data providers, as well as the controls and the receiving equipment. But it can be that the equipment and the sources of data can be on entirely different telecommunications networks. And they can often be quite difficult. It can often be quite difficult to get interoperability between the networks themselves so that the devices can interact. And so we found ourselves being drawn into some kind of translation environments almost between things like low power WAN networks and white space networks even, and sometimes between 5G and 3G, so that the test beds can actually operate properly with each other. And the equipment might all have the same kind of standards, but actually the communication mechanisms might make it very difficult for them to work together. And so an interoperable environment is really helpful there. And it's also something where there's the potential for mobile networks themselves to potentially be able to facilitate some of this by making it so that the edge-based components can immediately have a shareable structure about them. And that can actually work on edge components as well, although we haven't seen any of the network operators adopt that approach yet, or even have discussions with it so far.
Okay, thank you. Right, and I think we have seen some examples of others within the sort of telco ecosystem trying to create shared environments, for example, around common cell sites, and using digital twin concepts to allow all sorts of planners and involved. And I think there are some independent companies that have got some concepts around that as well. So I think there are examples, but not necessarily by telcos themselves, more within the wider ecosystem. I'm going to follow up with another question here from Mikkel, who's actually sort of, I guess the question is, do you see, or how do you see, in fact, consumer devices enter Iotic space, right the way to creating your own twin or digital twin within healthcare? Is that a viable proposition?
That's a very pertinent question. Within Iotic space, there are quite a number of private pieces of equipment because we've created an environment where you can operate in it free of charge. So it's kind of like an internet for things. As long as that data is publicly available, people can operate in it. Naturally, if you've got a healthcare device, people are more likely to want that to be privately held. And but strangely enough, only today have we had an extension where on a project we're doing for dementia sufferers with Essex County Council. This is at trial stage at the moment, but it's one where we're working with a healthcare provider and a specialist equipment provider to provide support for those that are sufferers. It would be great if we could see that coming into place because it creates a sharing environment between their home activities as well as the healthcare provider and public transport infrastructure and so on, which is great. But the healthcare provision for this is quite sophisticated and beyond the topic for today, really. But it's effectively creating lots of small twins that can interact specifically for that activity.
Great. I've just got a question here from Alexander, and his question is more about how do you ensure that the digital twin is kept up to date with the physical thing that you're twinning to. And I think the example here that Alexander's given us is if, for example, you add brick or something to a house, how is that change detected? And if you break the brick or something, how is that also detected? So I guess that's maintaining the accuracy of that trueness of the digital twin. Maybe you should just explain how does that need, or how does that alignment, how is that addressed within the ecosystem?
There's throughout the device life, or the thing that's being built throughout its life, events happen to it, and because the various things that are interacting with that created object are actually interacting with it. So you're adding some more cement, or you've added another pile of concrete to it, or you put in a beam or something of that sort. That's detected by the equipment in the surrounding community that are actually placing that beam in place or adding that window or whatever it's going on. And so it's possible to associate each of those events with the object that's now growing. And in actual fact, they build a history of that assembled object, so that actually there's a parallel, there's the twin of the real thing happening in the digital space. And so as a result of that, that event stream keeps on being added to and growing over the life of that product, and eventually becomes the twin of that product that then enters and builds a relationship with other twins. It sounds slightly naive to describe it like that, but it's like every time you put a bit of Lego on, you get a bigger picture, and you've still got the pile of Lego instructions sitting in your mind or in the corner, and it gradually builds up. Don't know how else to describe it really at the moment.
No, thank you, Paul. I'm conscious of time. We've got a couple more questions, lots of questions coming in. So thank you, all of you, for submitting them. The next question I want to pick up here is one on some of the monetization aspects. And I think the questioner is Raj, as he's talked to a large number of manufacturing companies which have digital twins, and they've not really seen a direct benefit or a return on investment in terms of those investments. And I wonder if it's if the question that Raj is asking that they haven't and someone else has, in other words, that it's not that it's adding value, it's just that they have difficulty in securing that value for themselves, or they can't identify the value, or is it that no value is being created? So it's quite hard to tell from the question what the problem is. But maybe in your experience, is that a problem? Those that develop digital twins then find that they can't justify, or they're unable to justify, or that someone else extracts the value and they don't?
It's a very good question, because we weren't sure how this would actually work out in practice. And we thought we'd been very clever by working out all kinds of good business models beforehand. And it actually turned out to be something where people gained benefits from something that was a lot simpler than we ever expected. And it happened, and I'll give you a great construction site example. And this is from Nuttall, who are a huge, a €7 billion organisation, but actually drove some innovation in here, and they were able to share information across a construction site. And very simply, they noticed within the first week that one piece of equipment that was being rented was only being used 6% of its time. That was less than 10% of its time, and yet they were paying for it as a full-time item. And this was because they were operating in an urban area, and they had a few processes that would create some dust, so they had to have a road sweeper on site, which they kept there the whole time. And nobody had noticed that actually it was hardly ever being used. And there are several other construction companies in that same street, and suddenly they could say, well, let's all have just the same road sweeper and share it between us. And it's things like that provide a very rapid payback that quite often people hadn't identified as a use case. And this is the difference, is that when you move to a digital twin, the real benefits often come when you start to use it from things that you had not thought of. And it's a bit like the idea of creating the internet. Nobody really knew all the different things you were going to use it for until you had that capability of exchanging things with each other in a way that you'd never thought of before. And that's what digital twins, as long as it's part of an ecosystem, does for you. If it just remains in stages 1 and 2, it's use case driven, very difficult to identify exactly, to get all those returns you're expecting. If you go to stages 3 and 4, then you get returns that you are not expecting, that make it so that we find people come back to us for more very quickly.
Yeah, and I think that's quite an interesting point. And just to kind of add on to it, at least through some of the conversations that we've had, where kind of the enablers or the providers of these solutions have been reached out to by customers, it's initially in that phase of, I need to make better use of my data. I've got a lot of data, but I don't know what I'm doing with it. So they help them and they implement certain solutions, which is a digital twin, but the customer doesn't necessarily know that. They just know that they're getting some kind of business outcome. And as Paul says, that's not necessarily where the real value comes. It's then when they discover, oh, we've got a digital twin, what can we do with it? And they start to move to beyond just a use case driven within their organization. That's, like Paul said, when they start to actually bring real value and start to actually notice some of the benefits of twins.
Great, I've got just time for another couple of quick questions. And the first one here is actually a question from Ken, which is a little bit related to what you've just said about investment and return. And the question is, in your opinion, and I'll start with you, Darius. Tough question. In your opinion, does the telecoms industry have the patience and the investment capacity to succeed in underwriting at least some of this, to bring about and help enable some of the digital twin ecosystem that has been described by Paul today?
Yeah, I think that's a really interesting question, and I think we've written quite a lot of research trying to spur telcos into doing more. And you mentioned the AI space, and I think that is a space where telcos have lagged behind kind of Google, Amazon, Facebook, and they should be doing more because they're in a much stronger position. But like you say, they are maybe stunted by bureaucracy, or they're just slow moving, and they have, I don't know, maybe focuses in other areas where they've focused on trying to roll out 5G, or they're focused on very specifically the IoT. And so I guess it's a good question, do they have the actual patience to start to deliver these? And I think they will do. I think, maybe not in the next 1, 2, 3 years, but I think what they'll find is that digital twins are so central to enabling a lot of what they want to do that they will start to invest in enabling some of this, and it will be kind of a key component.
So I'm just trying to get a last question, which actually follows on from here. Another question from Lakshmi, which really is, it's an early stage of introduction. When do you see, and you've kind of half answered it with your 3-year view there, Darius, but when do you see this technology coming more into the mainstream, and perhaps initiatives from vendors such as OEMs or software vendors and SIs implementing those solutions with and for operators? And I guess the secondary question here is this associated or dependent on 5G? So maybe I'll ask Paul that very, very briefly, because you've worked for many years within the telecoms industry, Paul, so I'm sure you've got an opinion on it.
Oh, it's me.
Yes.
Well, I can imagine that the diversity of data from various sources, 5G, interestingly enough, and perhaps even NB-IoT and all these other sources, they're generating large amounts of data. There's obviously a diversity of applications here. What will be interesting will be to see how many of the device manufacturers work in conjunction with the mobile network providers to make it so that actually devices can come into existence and work in relationship to each other out of the box. And that will be very significant when we get to, especially with autonomous vehicles, where the need for edge compute and locally defined environments need to interoperate very effectively and very quickly. That's where there's a massive opportunity to bring this into place.
So I think we've run out of time, but thank you both, and thank you also Yasmin, who's been managing the chats. We'll have a sort of slides will be shared with all the participants, and we'll be also reviewing some of the questions and maybe getting back to individuals with the responses. So thank you everyone for joining us today. Thank you very much, Paul, for taking part. Thank you very much, Darius, and have a good afternoon, evening, morning, wherever you are, whatever time zone. Goodbye.